Hello, ladies and gentlemen. Time for a little lesson about different forms of quadratics. So, remember once upon a time we learned about like equations of lines and how we can actually write them in a little bit different ways. Like we got y equals mx plus b. But then there's also sometimes it looks like this. We would call this a quote-unquote standard form. It's just like something x plus something y equals another number. That's not all of them. There's also point slope form, which is this guy, which you might have seen last year. But these are all different ways to like write the equation of a line. Well, there's multiple ways to write the equation for a quadratic. So the one we've been using most of the time is what we call standard form. It's just ax squared plus bx plus c. Well, there's two other types that you have to get used to. One is factored form, which we'll be learning about next time. And then today we're learning about vertex form. Vertex form is actually very helpful when we get to graphing quadratics coming up here. You got to be able to like know what all these numbers mean, and it helps you graph things. And so we're going to be today figuring out how to write quadratics in vertex form. And the reason it's called vertex form is because it has the vertex of your parabola and your vertex of your quadratic in there. So remember when we graph things in the calculator, we get a parabola. It's called parabola or quadratic like this. And we have a highest or lowest point. This highest or lowest point is called the vertex. And the quadratics can go this way, so this is also be a vertex. So the vertex is just the highest or lowest point of your curve there. Well, let's go through and kind of walk through how to write out the vertex form of a quadratic and convert it to standard form, because you got to be able to convert it to standard form as well. And so your steps are here. You're going to plug in your vertex into your vertex form of your quadratic. The coordinates of your vertex are the h and k in here. So here's h, here's k. And those are going to go in the h and k spot of our little formula. And then x and f of x are just going to stay where they are. So let's put some things in here. So first step, we got f of x equals, it's going to be a times x minus h squared, and then plus k. So these are the first two blanks we're going to be putting in. Your vertex is in the form h comma k. And so here in this case, h is 2 and k is 4. So I'm going to put those two numbers in. Our next step is to take the other points that the parabola passes through and plug it in for x and f of x. And so let me kind of show you what that looks like here. We have this point. Yes, we know the vertex, but we also know that this quadratic passes through this point. This is an x value, and this is an f of x value or a y value. We're going to put this here in the x spot, and we're going to put this 6 over here. It's in the whole spot, not just the x. So when I put those numbers in, I got 6, and then 1, and then everything else is still the same. We got a parenthesis minus 2 squared plus 4. So those are the new things that we've inserted there. Well, the next thing we need to do is solve for a. A is this thing. The reason we even have to plug a point in is because we don't know what a is, and so we have to do a little bit of solving. Well, luckily this isn't too bad. You can do 1 minus 2 and square that. Let me draw that down here. Got 6 equals a times, well, 1 minus 2 is just negative 1. And when you square that, you're going to get, well, 1. So it's a times 1, or just a, plus 4. We can do a little bit of solving here. Let's subtract the 4 over. Yes, it's thundering outside. We got a times 1 is just a, so a is 2. Hooray, we got it figured out. A is 2. Nice. Okay, so now we have h, k, and a for the vertex form. We're going to plug them all in and see what we get. So f of x is going to come back. The a value is going to go in the a spot. It's still x minus 2 squared plus 4. And that's from here. So I'm just taking my vertex form that I was working with, and I'm putting the 2 in for the a that was right there. Okay. So hooray, we got it. This is the vertex form of this quadratic that has a vertex at 2, 4 and passes through the point 1, 6. Cool. Well, the next thing we need to do is we're going to convert to standard form. To convert to standard form, really you just need to take this right side and simplify it down. Well, you know, it's one thing to say that, it's another thing to actually do it. So an important thing to remember is that when you have something squared, that means it's two of those things times together. So you got x minus 2 times x minus 2. So that's this piece. And then plus 4 still on the end. Well, we need to simplify this piece before we can do any adding 4 that's required. I like to do the binomials part first and times them together. So we'll keep 2 out here. But these will times and times and times, you know, double distribution there, or like we've done before. You're getting x squared minus 4x plus 4. And this plus 4 still on the outside. Now we've dealt with these things, we're going to deal with the 2 in front. So we're going to distribute the 2 through to all these terms. And that's going to give me 2x squared minus 8x plus 8, and then plus 4. And then these last 2 terms, they do combine because they're constants. There's no variable with them. And so we're looking at 2x squared minus 8x plus 12. And yes, there's my standard form. So this one here is vertex form, and this is standard form. These are the exact same quadratic. If you were to graph them, they'd be the exact same thing, but there's 2 different forms for representing the quadratic. Okay, and so let's do these 2 examples here. Your assignment looks like this. You're going to do part A. For this part, we will talk about part B in the next video, in the next lesson. And on each of these, you're given a vertex and a point that it goes through. And so let's go ahead and try this one out. Once again, you start out with f of x equals a times x minus h, and then plus k, whatever those are. Well, here's my h and my k. So h is going to be negative 3, and k is going to be negative 1. So we can actually simplify that a little bit just with the signs there. So we got a times x plus 3. If you minus negative 3, it's the same thing as plus. And if you add negative 1, that's the same thing as subtract 1. So we just simplify that a little bit. Our next step here is to temporarily take these numbers and put them in. So this is x and f of x. So x is going to go in the x spot, and negative 5 goes in the f of x spot. And let's write out what we get there. We get negative 5 equals a times negative 5 plus 3 squared minus 1. The next thing I'm going to do here is solve for a. So I'm going to do some simplifying here. It's going to be a times negative 5 plus 3 is negative 2. I'm going to square that. Negative 2 squared is 4. And then minus 1 equals negative 5. I'm going to add 1 over. Now I got negative 4 equals 4a. And let's divide by the 4. And I got that a equals negative 1. Cool. So I got my a value. I'm now going to take this and put it back into my vertex form and write out what that all comes out to be. So I'm going to draw a little line here, separate things. I got f of x equals negative 1 times x plus 3 squared minus 1. Okay, this is the vertex form. I do want you to convert it to standard form. It's like this is right so far. We just need to do a few more steps here, which again, I'm going to times those together. It is x plus 3 times x plus 3 minus 1. If you are fluent in trying to convert this to the trinomial, go ahead and do that. I'm just putting this step here so you can see what's happening. I need to do x plus 3 times x plus 3, so x times both of those, 3 times both of those, and combine things together. We've done a lot of factoring, so it's kind of like going backwards on factoring, just double distribution. It's going to add up to 6x in the middle, and then plus 9 on the end. I'm now going to distribute this negative 1 through to get negative x squared minus 6x minus 9. And the minus 1 is now available to combine with the others. I got f of x equals negative x squared minus 6x minus 10. And now I've got it in standard form. So vertex form up here, standard form down here. So there's that example. I would like for you to try out the next example on your own and see if you can go through it. So pause, come back and check. Okay, did you pause? Did you check? Well, it's checking time now. So let's try this out. So we got f of x equals a times x minus something squared plus something. Here's my h, here's my k. So this is 0 and this is 6. That means this doesn't really do anything. We got a times x squared plus 6 equals f of x. Now I can plug my numbers in. 3 goes here, and then 2 goes over here. So we can get 2 equals 3 squared. Sorry, a times 3 squared plus 6. 3 squared is just 9. So this is 9a plus 6 equals 2. Let's subtract the 6 over. Now we got negative 4 equals 9a. Let's divide by the 9. And now we got a is negative 4 ninths. Ooh, a little tricky. It's a little fraction. Do not let fractions scare you. But yeah, there's fractions. Let me get those out of the way so they get a little easier to see. Now I'm going to plug this a value in here and simplify it down into standard form. So I got f of x equals negative 4 ninths x squared plus 6. And simplifying this down is pretty easy. This is just x squared. So it's negative 4 ninths x squared plus 6 equals f of x. And that's it. That one simplified really easily just because x minus 0 doesn't... when you square that, you should get x squared. Easy peasy. So yeah, sometimes your a value is a fraction, and that's totally fine. So give this a shot on your assignment. Plug in the vertex to get your equation started, then plug in the point temporarily to get the a value. Once you have your a value, you do not include the point anymore in your equation, and so you revert back to the f of x and x. So yeah, give it a shot, see how it goes.